Good morning to one and all. I'm Dr. Sumitra from CSC department. Today's session, today we are going to discuss about the representation learning in deep learning architecture. The representation learning, a cornerstone in deep learning architecture, focus on learning an efficient representation of data. Unlike a traditional machine learning approaches, where the features need to be manually engined, representing learning automates this process by learning a meaningful representation directly from the raw data. The essence of representation learning lies in the extractions of high level feature that captures the underlying structure and semantic of the data. This paradigm shifts the revolution to various fields, including the computer vision, natural language processing, and the speech recognition, enabling the algorithms to achieve a remarkable performance on a complex task. The basic technique used in representation learning is autoencoders, deep learning neural network, word enabling graphs neural network, generative adversarial network, self-supervised learning, transfer learning, and so on. These autoencoders or the neural network trained to reconstruct their input. They consist of an encoder network that compresses the input data into a lower dimensional representation, latent space, and the decoder network that reconstruct the original input from this representation. By enforcing the models to capture the essential features of the data in the latent space, the autoencoder learns a meaningful representation suitable for the various downstream tasks, whereas a convolution neural network excels in capturing a spatial hierarchy features in data such as images by employing the evolution layer with the learning filters, and CNN can automatically extract their shapes from the raw pixel value. This hierarchical representation enables a CNN to achieve the state of art performance in image classification, object detection, semantic segmentation task. And the recurrent neural network or adapted capturing a sequential dependency in data, making them well suited for the task involving a sequence such as a natural language processing and time series prediction. Through a recurrent connection, RNN can maintain an internal state that retains information about a past input, enabling them to learn a rich representation of sequential data. A generative adversarial network is all about is consisting GAN consisting of a two neural network, a generative and a discriminator enabled in a game theoretical framework. This generative aims to produce a realistic samples from the random noise, while the discriminator distinguish between the real and generated sample. Through adversarial training, a GNN learns to generate a high quality data samples, thereby implicitly learning a representation of the underlying data distribution. The word embedding is in the natural language processing, the word embedding map words from the high dimensional space vocabulary to the lower dimensional continuous vector space. These techniques like word2V, envelope, and fast text learn a distributed representation of the word that capture the semantic relationship and contextual information. These embedding serves as a powerful features for various NLP tasks including a sentiment analysis, a mission translation, and the name entity recognition. The applications of representation learning is all about image recognition. Representation learning has revolutionized the image recognition task by enabling the model to automatically learn the features directly from the raw pixel values. The CNN, trained on a large scale data sets like ImageNet cells, can extract hierarchical representations of image, allowing for accurate classification, object detection, and image segmentation. This natural language understanding, in where it facilitates a task such as sentimental analysis, text classification, and mission translation. The word embedding learned through the techniques like word2V, envelope capture, semantic similarities, and so on. And we have a healthcare where the representation learning finds extensive application in healthcare, including a disease diagnosis, medical image analysis, and drug discovery. By learning a representation from the medical image, EEG signals, and the patient records. Deep learning models can assist a clinical in learning and detection, personalize the treatment planning, and drug reprocessing. And the recommendation systems where the representation building plans a crucial role in recommendation system by learning a latent representations of the user and the item. Hence, I conclude that the representation learning has merged as a fundamental paradigm in deep learning, enabling the models to automatically learn a meaningful representation directly from the raw data. I hope you understand with this concept. Thank you.